Now in the previous lecture, we have talked about hashing terminology. Now in this lecture, let's talk about hash functions. So to understand it very clearly, I will explain two sample hash functions over here. So the first one will be for the integer numbers, which means input from a user will be integer number. So in this case, it's going to be very simple hash function. Now the second case will be when a user input will be a long string. So this one will be more complicated compared to first one. So let's look at first function. So in this case, we will use mod function, which works for only integer inputs. So what does that mean? So let's say this is our hash function. So it's going to take as a parameter number and number of cells that we have in our array. So in this case, in our array, we have 24 cells because it starts from 0. So that's why the number of cells is 24. So whenever we are inserting an integer number to this array over here, we are going to divide that number with the 24. Then we are going to get the remainder and insert the number at the index of remainder. So to make it more clear, let's look at real examples. So let's say we want to insert 400 to this array over here. So in this case, we are going to call this function with the first parameter 400, and the second parameter in our case is 24 because the number of cells over here is 24. So if I divide the 400 by 24, the remainder will be 16. So this means that we can use this 16 over here as the index of this array and insert 400 to this index. So in this case, we are going to insert 400 to the index of 16. So let's continue to the second example. Let's say we want to insert 700 to this array over here. So in this case also we are going to divide it by 24 because in this case also we have the number of cells in our array 24. So if we divide it by 24, we are going to get 4 as a remainder. So in this case, we are going to insert 700 to the index of 4 over here. So here you can easily see that the number 400 get reduced to 16 and the number of 700 get reduced to 4. Now you might be interested why we are reducing it. Because our array over here has only smaller indexes. So we need to insert them based on the indexes that we get from this function over here. Now after calculating the mod of these 400 and 700, we have found their indexes. So we can easily insert them at the indexes that we get from this hash function over here. Now whenever we are dividing 400 by 24, the remainder will always be the same. And it's applicable for this case also over here. Whenever we are dividing 700 by 24, the remainder will always be 4. So this means that if we want to access these cells over here, we can calculate their indexes by using same function, and by using this index we can access these values over here. So this means that this makes our search operation very fast, and in this case the search operation for hash function will take a one-time complexity, because in this case if you look at this function over here, we are just doing simple calculations and getting the remainder. So by using mod function over here, and getting remainder will take a one-time complexity, and accessing a cell value in an array using an index will take a one-time complexity. So this means that in our case, searching using hash function will take a one-time complexity. So this is the main reason that we are using the hash function. So in this case, we have successfully implemented hash function for integer numbers. Now let's look at the second case. In the second case, as I've mentioned before, the input will be string. So how do we convert these strings to the number? So here in this case, our function will be like this. So in this case, first we are going to find the ASCII values of characters and sum them, and at the end we find the index by dividing it with the number of cells in the array, which is in our case 24 over here. So for example, let's say we want to insert ABC to this array over here. So as I said before, the number of cells in this case is 24. So we are going to call as a first parameter string that we want to insert, and as a second parameter number of cells. So in this case, it's going to be 24. So this means that the next thing that we are going to do, we are going to find each character's ASCII value. So in this case, based on this table, we can easily identify the ASCII values of the characters. And by writing this function over here, we can easily find the ASCII values of these characters over here. So whenever we are summing up the characters, it's summing up their ASCII values in Java. So in this case, first we are going to identify the ASCII value of A. So here you can easily see that in this table, ASCII value of A is 65, for B is 66, for C is 67. So what we are going to do, we are going to sum all of them. So if we sum up all of them, we are getting 198. Then we are going to divide this 198 by 24, and we are going to find out the remainder that comes from this division. So here you can easily see that if we divide it by 24, we are getting 8, and the remainder is 6. So this means that we can insert this ABC at the index of 6 over here. So if we insert it, it's going to be like this. So whenever we are accessing this value over here, we are going to call this functional mode ASCII function over here. So this function will always return the 6, because in this case the ASCII values are constants. So if you sum up them and divide them by 24, it's going to be the 6 always. So that's why if we want to search for this string in this array over here, we can easily use this function, and the time complexity for this search operation will be O1. So this is how this hash function works in this case. So hopefully you have understood how hash function works and what is the logic behind them. So with these two examples, I have shown you two different hash functions. The first one for the integer numbers and the second one for the strings. And for strings, we have used ASCII values of the characters over here. So as I mentioned before, these functions that we talked over here are very simplistic. So when we face problems in real life, we cannot solve them by using these functions over here. The reason that I've explained these functions over here is that to understand the logic behind them. So to choose the best hash function, we need to know that what defines a good hash function. So let's learn some characteristics of good hash functions. So the first property of hash function is that it distributes hash values uniformly across the hash table. So what does it mean? So let's say our hash function is like this, and we want to convert strings by using this hash function to the integer value, and by using their indexes, we want to insert to this array over here. So let's say I want to insert ABCD to this array over here. So by using this hash function over here, we can convert it to integer. Now after conversion, we see that we are getting 20. So this means that we can easily insert ABCD at the index of 20. So we see that index of 20 is empty. So we are going to insert it over here. Now the second string that we want to insert is ABCDEF. So if I want to insert this ABCDEF using hash function, we are going to use hash function to convert it to the integer. So after conversion, we are getting the value of 20. Now if we want to insert this ABCDEF to this array over here, we see that at the index of 20, we have another value. So this means that this is going to cause collision. So in this case, we face a state of collision. So to resolve a given collision, it's an extra overhead. So this means that this hash function over here is not good hash function. So we always implement a hash function which distributes cell numbers uniformly. Otherwise, if the cell numbers are same, then in this case we are going to face the state of collision. As a result, you need to be very careful that we always want to avoid any condition of collision. So if our hash function causes many collisions, in this case it means that this is not good hash function. So the property of this hash function says that it has to distribute the hash values uniformly. That is not causing the collisions over here. Now the next important property of hash function is it has to use all the input data. So let's say we have two strings over here and we want to insert them to this array over here using hash function. So in this case, if our hash function use the first three characters of these strings, in this case it's obvious that the value that we are getting from the hash function will be same, because if I use only ABC for the first string and we get 18, so for the second one, if I use only ABC, which are the first three characters of this string, in this case it's going to be 18. So this means that same characters will produce the same output, and this one also will cause collision. So here again, for ABCD, if I use only ABC, it's going to return 18. So if I put ABCD at the index of 18 and use the same function for the next string, so in the next string, so you see that first three characters are same, so it's going to return the 18 for this case also, and it will cause collision in this case as well. So this is not desirable in case of hash function. So as we said before, if we have collisions, in this case, this is not good hash function. So with this, we have come to the end of this lecture. So in this lecture, I have explained you the logic behind the hash functions, and we have learned what defines a good hash function. So hopefully everything is clear about this lecture. So see you in the next lecture.